after you can get a proposal in to discover new continents. We got a pretty good map. Now, though, we want to understand how the continents form, what the forces shaping it, and what are the details and how they're going to evolve and how is the climate going to change. So you have a certain area where you've actually made enough progress that you can actually define good questions. And so the other advice I give to young researchers is pick an important question, but an important question you could get done in 5 years, right? Because you've got to move on with your career, right? And if you think it'll take 5 years, it'll probably take 10, or in my case, 20 years. And you want to get it done, you know, in a timely way. Not that I didn't do other things along the way, but you have to be able to choose problems that are not only important, but that you get done. And so I don't know. I can spend my time helping to get a dark energy mission going because my career is fairly well established, and it will only be hurt some if it fails or takes 10 extra years, right? But it's a really important and challenging question, but it may take 100 years to understand what dark energy is or to find another theory of gravity. But the dark matter is something you can go after. Clearly, the cosmic microwave background was coming right. The technologies were coming together. There were newer and better electronics and radio receivers. There was the opportunities to go higher and to go into space. And there were new techniques that you can do, and computers coming along to analyze it. There are new areas that are opening up. We can use gravitational lensing to the fact that something that Einstein thought would never be observed now is going to be a routine tool. We can look at light from very distant quasars and galaxies and see how that light is bent by the intervening material, including the light from the cosmic microwave background, the beginning of the universe. We can see how it's slightly distorted by the fact that space is distorted, and that'll tell us about the intervening matter and energy. And you can also use it to learn things about the trajectory of the universe. So not only do we study the trajectory of the universe as a whole, but we can study how structure grows, and we can study how matter is distributed. Those are tools that we didn't have 20 years ago, and we have now. So that there are opportunities, but they are tools that require good mathematics and tremendous computer systems, and those are available now, and we can do those kind of experiments. So there's lots of interesting challenge. So my advice to young researchers is, I have a list of 8 questions. Any one of them are important. Pick out the one you like the best and you think you can get done in 5 years, and team up with people and do it. Science is now a worldwide effort. You know, I have collaborators in the United States, in Europe, and now in South Korea. This is a pen for Ewha University, Ewha Women's University in South Korea. We have collaborators there. We're going to be looking for collaborators from all around. I have a student working in my group from Singapore, right? It's just down the street. And, you know, we need the brain power, and we need the excitement, and it's a worldwide effort because it's your heritage too. It's everyone's heritage. We all came from the Big Bang. We all live on the Earth. We want to know how the world got created. That is, how the universe got created, how the galaxy got created, and how the Earth got created. We also want to know how to save the Earth, right? We're having a tremendous impact on it.
Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.
I'm sorry, what was your name? Don't be shy, just tell me.
You are welcome. You are welcome.
Pleased to meet you.
One of the Islamic countries. My name is Muhammad Turba Saeed. I am working as a lecturer in Islamic Studies at the Faculty of Islamic Studies at Johor. I hope to ask you some questions. I understand from your talking the universe is expanding. Universe is expanding, and the scientists discovered that at 20th century. But we know that already in 7th century, because we have in the Holy Quran one verse, أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم والسماء بنيناها بأيد وإنا لموسعون. The meaning is Allah has created the universe, and the universe is expanding. My question is, if the universe is expanding, one day will bomb or not? Yani it will has end or not? And from what the universe is created? from what material the universe is created, because we have in the Holy Quran, the universe is created from material same like smoke. Smoke material same like smoke. This and also I want to ask, which is moving faster, the sun or the moon, which is moving sun? Because we have in the Holy Quran one verse also is talking about that the moon is moving faster than the sun. That's all. Thank you very much.
Okay, so there's many questions there. And so let me start with the easy one about what's moving faster, the sun or the moon. And so what we learned in physics is as long as we have simple things like conservation of momentum and energy, they are telling us something about the properties of space and time. And that tells us as long as those are conserved, that all motion is relative. There's no absolute standard of reference. There is a frame in which the expansion of the universe looks particularly simple, just like there's a frame in which the motion of the Earth around the sun looks particularly simple, right? So the question about which is moving faster, the sun or the moon, is it's a question of where you choose to observe from, right? You could do it from on the Earth, or you can do it from on the sun. If you're on the sun, the sun is not moving at all, right? And the moon is moving fast. If you're on the Earth, the moon is going around, right? But the sun is going around, and the sun is further away, and it's going faster. But that's a question of you have to finish defining the frame, right? So there's the other question about what's the universe made out of and so forth. I thought you were going to ask me a religious question about if there's a contradiction between religion and studying cosmology and the birth of the universe, because clearly in most religions like Christianity and Islam, the God is Allah is the creator of the universe, and I think that could easily be true, and that in fact studying the universe is studying God's creation. And the nice thing is it's another form of the writing of God to see the universe, right, in terms of what's happening. And we don't know the answer to which the universe came from. There are several different theories about the beginning of the universe. One of them, the universe comes from nothing. It's not only small, it's absolutely nothing. And in the case that the universe happens to be perfectly flat and therefore now effectively infinite, although there used to be geometry in destiny, the dark energy kind of provides a little fuzzy area in there. In that situation, the total energy of the universe is zero. That's like saying the total cost of my house is zero, because I found a lender that would lend me 100%. This is a bad thing to bring up these days. That I found a lender that would loan me 100% the cost of my house. So I borrowed the money and I bought the house, and my net worth is zero. I owe, $100,000 to the lender, and I have a house worth $100,000. And that was fine as long as the value of the house went up. But when the value of the house went down, that wasn't so good, right? And it became part of the world economic crisis. But in the case of the universe, the bookkeeping is much better. And in the case of the universe, we know we're very close to a zero net energy case. That the beginning of the universe came from a very small amount of material, and people have done calculations, including Alan Guth, who was one of the inventors of inflation, that had you had sufficient resources and energy, with simply 10 kilograms of material, you could produce a baby universe that would grow and become as big as our universe. Now, I have confidence that if you had a lot more time and a lot more intellectual power, the way Allah would have, you could do it for less. Right? The universe would be a bargain, and not only that, I could answer the question. I had more time, and I was hoping with someone to ask. I could answer the question: why are there 100 billion galaxies when one would have been enough for mankind? And the answer is, if you say the laws of physics are the laws of God, then you say quantum mechanics tells you that when you start off with a very tiny universe, quantum mechanics is very important, and there must be quantum mechanical fluctuations. But when I went through the accelerating expansion of the universe called inflation, and then the continuing expansion of the universe, things grew by 60 orders of magnitude, and things that were smaller than an atom got to be bigger than our galaxy. So our galaxy was once a quantum mechanical fluctuation, so is that Coma cluster of galaxies, and so is the Great Wall They were once quantum mechanical fluctuations. They were microscopically small in physical size, but they got stretched to astronomical sizes. And that when you go into a very tiny region, which the universe was made from, was very dense, but very tiny, and you're going to have hundreds of millions of quantum mechanical fluctuations. Therefore, you will get hundreds of millions of galaxies, and there's nothing you can do to stop that unless you can violate the laws of quantum mechanics. Right? And so it's a very beautiful picture. It's very economical in many ways, but it has all these strange new elements in it, right? That you know you must have, and that's it's kind of the universe exposing itself to us and saying, here's another veil, here's another mystery for you to explore. And so for me, it's very exciting to learn about this.
My name is Selma. I'm a PhD student in Brunei, Dar es Salaam. I have a very short...
Closer to the microphone. I heard your name is Selma.
Yes. I would like to ask a very short question. What is the purpose of a dust as a matter in the universe? Thank you.
So the question is, what is the purpose of the dust? And of the which?
As a substance, as a matter, energy matter in the universe.
All of it, or just the dust?
Just the dust.
All right. So this is the question about why did God make flies, kind of thing. No, the dust is an automatic consequence of producing stars and having the stars burn the primordial elements from the Big Bang, the way Gamow and Alfred Herman calculated. You have this primordial material, stars form, they do nuclear burning, fusion, and they produce the heavier elements, and then the stellar winds take those elements out, or supernova take those elements out, and they turn them into huge clouds of gas and dust. And the dust will coalesce more quickly because it can radiate electromagnetically better. And a lot of the dust is made of carbon and water, carbon molecules that make these carbon fibers, and water molecules that form together, and they freeze, and they make sort of dirty dust particles, carbon nanotubes kind of materials. And it's a very effective radiator, both because of the particular atoms, but because you get a larger structure, you get a more complicated. So they actually cool more quickly, and they make clouds, and those clouds then actually help the next formation of solar systems after that. But it's not, I don't know if that's a part of a plan or whether that's just a byproduct of the plan that when you burn, wood for heat, you end up getting ashes, right? You're burning nuclear elements, and some of the ashes you get are dust. That dust turns out to make dust clouds. It also turns out to eventually make planets and in places where you get life. But many of those dust clouds have a lot of interesting molecules in them too. So many molecules have been discovered by radio astronomers in space, and they're good radiators, and you see molecules. You see, I think several, almost most of the amino acids have actually been shown to exist in molecular clouds in space, right? So they're molecular and dust clouds. And so there's a lot of active chemistry. That's the wonderful thing about cosmology, is you've got to know particle physics and nuclear physics. You have to know everything. It's fun. It involves, it recapitulates all that we've learned in science. So thank you for the question. And thank you all.